In this video, we're going to look at combinations, and when order is not important, we're going to use combinations, and that is a typo here. That should say combinations. And one way to help you remember order is not important to use a combination, because really the terms are a little bit confusing. Because when I think of a combination, like a locker combination, order does matter. So that's really a permutation. So that word can confuse you, but the way I remember it is order is not important. So the acronym order is not important is in the word combination. So we have the formula here, and we're just going to plug into the formula. It's just n and x like normal, but we have an extra part here, x factorial, on the bottom. There's no shortcut for this one. You actually do have to use the formula unless you list all of your different outcomes out, or your different combinations. So let me just show you what I mean here. Suppose we had letters A, B, C, D. How many combinations are possible? Well, order doesn't matter, so AB is the same as BA. So for a permutation, we would count both of these, but for a combination, they mean the same thing. If you get AB or BA, those would be the same. So combinations, if you were to calculate this using a combination and using a permutation, combination is going to be actually a smaller number. Let's look at some homework problems. Okay, so in this one it says if the order of objects is not of importance, how many ways can 20 objects be selected 3 at a time? So 20 objects 3 at a time. So our sample is 20 and x is 3. So 20, and you can do this in a TI-83 or 84, but it really doesn't take long to do. So n 20 factorial over 20 minus 3 factorial, and then another 3 factorial. Make sure you write this down so you can just plug it straight into the formula. So on the bottom, I like to do that first so I know what I need to get to cancel out on the top. On the bottom, 20 minus 3 is 17. So I need to count down to 17 and then just cancel those. So now I can do 20 times 19 times 18 over 3 times 2 times 1. And that would be 6 on the bottom. And there, you could cancel out some things, but 20 times 19 times 18 would be 6840 divided by 6. So there is 1,140 ways that we could arrange 3 objects at a time. Explain why this is different from the result when order matters. Well, we just talked about that. When order does not matter, picking the first object before the second object is the same thing as picking the second object before the first object. So the number of ways of choosing is going to be less when the order does not matter. Remember, AB is the same thing as BA. Okay, here we are selecting jurors, and we're selecting 12 from a group of 60 people. So how many different juries can be selected? So here, if we select the number, we don't really care if the same juror is juror number 1 or juror number 2. That really doesn't matter. We're not going to count that twice. because we're not talking about finishing first, second, or third where order would actually matter. So we're going to use a combination, and you would work it the same way as we just did, except now we have n is 60 and x is 12. Okay, so just to make sure, let's just say we had a jury of 3 people, and we had John, and we had LaTanya, and we had Trey. Okay, so if we had a juror of 3, well, what if we had Trey on at seat number 1, and then John at seat 2 and LaTanya at seat 3? Does that matter? No, they're still on the jury, and it's still the same people. They're just in a different order. So we would not count that twice, just to make sure that makes sense. Okay, so N is 60, C 12, if you're putting it in the calculator. So 60 factorial over 60 minus 12 factorial, and then 12 factorial. Okay, so this one would take a little bit longer because on the bottom you have 48 factorial and 12 factorial. So you would have to count down to 48. Which this is a lot of numbers, but still it's not as bad as it looks. 12 factorial, what you can do is you can put 12 factorial in your calculator, or you can use Excel. So I'm going to pause it and show you how. Let me open Excel real quick. Okay, so let me zoom in to show you how I got 12 factorial. You're going to put in equal factorial, it's fact, and you can do 12. Now what you could do on the top, instead of having to multiply all of that in your calculator, you could just put in 60 factorial on the top. So equals factorial 60. Okay, and then the bottom, let's just do equals factorial, what was it, 48 on the bottom, times factorial 12. Okay, so this is the numerator. So now we're going to divide the numerator by the denominator. And you're going to get a, let me expand this. Okay, there's your number. And I almost thought that that was wrong, but that's actually how large the number is. That's how many different jurors or juries we could have. Okay, this is another combination. It's a jury, but we want a 6 men and 6 women. And we're selecting from a group of 15 men and a group of 11 women. Alright, so order's not going to matter here because the order of the jury doesn't matter. It's a group. So we are going to do a combination, but we have 2 combinations here. We have to do the combination for the men, so 6 men out of 15. So let's do that one first. So That's going to be 15 times 14 times 13 times 12 times 11 times 10 times 9. And that's going to cancel. And then 6 times 5 times 4 times 3 times 2 times 1. So on the bottom, that's going to be 720. And then the top, I'm going to pause it and plug that in. Okay, and you'll get 5,005. So that is for the men. That's the total number of groups of men. Now we have to do the women. And I know that we're going to select 6 women out of 11. So this time we're going to do 11, 6. So 11 times 11 minus 6 over 6. And I'm going to stop with that 6. And then I'm going to plug this into my calculator. Okay, and so when you do that, you get 462 for the women. So we have one combination here and another combination here, and we want to know the total number of combinations for the whole jury. So what you're going to do is use the fundamental counting principle. So if there are K1 choices for the first event, so that would be the 5,005, and K2 choices for the second event, that would be 462, then the total number of outcomes you would get by multiplying. So if you multiply 5,005 times 462, you're going to get 2,312,310.